Hi Pre-Calc. Today we're going to do 4.1, which is radians and degree measure. And the idea is that we have an initial side that we are going to rotate a certain amount to a vector of a terminal side. So you have like two vectors that are connecting here to make an angle. So you have the initial side vector and the terminal side vector, and we're going to rotate from the initial to the terminal side to get an angle of theta. Now, when you talk about theta, let me just see if I can fix the shadows a little bit. Okay. When you talk about theta, there's a couple different units that you can use for an angle. There is degrees, there's radians, there's degrees, minutes, seconds, and there's what's called gradients. Now, we're going to stick to degrees and radians, so I'm going to run through that with you briefly now. Most of us are a little bit familiar with degrees. We're going to do a mix of fixed trig, which is like a triangle, and rotational trig is when you go around an axis. So when you're doing rotational trig, you always start in what's called standard position. Standard position is always the positive side of the x-axis. The positive side of the x-axis. This is always standard position. When you do rotational trig, you always start here. Okay? So let's just start with degrees. So in rotating, you rotate, positive is considered counterclockwise. All right, so if you start here, this is 0 degrees. When you get to here, this is 90 degrees. When you get to here, this is 180 degrees. When you get to here, it's 270 degrees. And then back to finishing the circle, you're now at 360 degrees. And you can keep going around and around and around, okay? But those are like some real important ones. We can also cut up like one quadrant. So the angles in degrees that are really important are the cuts that are in terms of 30 degrees, in terms of 45 degrees, and in terms of 60 degrees. Those are really important cuts, and you'll see as we get more into trig that those cuts anywhere off of like the horizontal or the, really off the horizontal is how we look at it. Those cuts are really important. Okay, let's now take a moment to sort of discuss radians. Radians is the one that you're going to have a little bit more difficulty with. And let's just start by going over the definition. So 1 radian is the measure of a central angle that intercepts an arc S equal in length to the radius of the circle. Algebraically, this means that theta equals to S over R, where theta is measured in radians. Note when theta is 1 and S equals to R. So the idea is when you open, if I have a circle of radius 1, if I have a circle of radius 1 and I open an arc length of 1, then that angle in here is considered to be 1 radian. Okay? If I have a circle that's radius 3 and I open an arc length of 3, then that's considered to be 1 radian, right? Are you catching that it's proportional? Right, it's proportional. So you could probably guess what I'm going to say here. If I have a circle that's radius 5 and I open up an arc length that's equivalent to 5, then that means that that's 1 radian. Okay? Now radians are going to be the one that you're going to have like a little more difficulty learning, but you'll catch it, okay? So let me just overlap it on this. Maybe let me do it in a different color so it's a little easier for you. So in radians, you would say 0 radians. It just wouldn't have like the little degree symbol on it. Here at 90 degrees, that's equivalent to pi over 2. I just gotta watch, my camera's giving me, it needs a battery check. Okay, at 180, that's pi. At 270, that's gonna be 3 pi over 2. And 1 full 360 would be equivalent to 2 pi. Okay, so 1 full rotation is actually 2 pi's. Half a rotation is 1 pi. And let's just do the little subcuts. So 30 degrees is equivalent to pi over 6 in radians. And 45 degrees is equivalent to pi over 4. And 60 degrees is equivalent to pi over 3. Now, please note that the default is in radians. So if somebody just says 3, they don't mean 3 degrees, they mean radians. If you want to say degrees, you actually have to say 3 degrees, okay? If there is no degree unit here, the default is that you're to assume it's in radians. We have a habit of thinking if something's in radians, we're going to see a pi. That's not true. That's not true. Radians is a unit. Whether the pi is there or not, the default is radians. Okay, gang, that's the intro. I'm going to pick up again more with 4.1 momentarily. So I'll catch you again soon. Bye-bye.